Hello, everyone, and welcome to Automation Fair 2020. My name is Paul Didier. I'm with Cisco Systems. I am in our IoT on industrial networking and cybersecurity. I'm a manufacturing solution architect, and I'm here to give you a brief overview of wireless access technologies used in production environments, looking at some use cases and some of the key technologies. In this presentation, I'm just going to kind of run through some key questions and answer those questions, and then kind of summarize quickly at the end. Anyway, let's get started with our first question. A lot of people ask, what do we see are the key trends in production environments regarding wireless technologies? What are some of the key use cases that are coming up? Let's take a look at that. First, I would broadly say production environments are becoming much more mobile, much more flexible. Customers are looking at running, more robots in these production environments, making them mobile. Anything mobile usually has to have wireless connectivity to it. So we're seeing a real explosion of use cases around wireless access technologies. Some of the other key use cases there, social distancing, where you're trying to sense whether people are getting too close to each other, and if so, kind of like identify those events and maybe communicate with those people. More and more smart devices are coming into the production environments, helping the worker on those in those environments work more efficiently, more effectively, more interconnected with experts and other folks around the globe. I mentioned as well an explosion around automated guided vehicles, robots, and other things to basically help automate some of the work people did, or just improve environment. So we're seeing a lot of that. Surveillance cameras are finding their way into more and more production environments, not just watching people or securing the perimeter of the production environments, but also being used to for quality control or watching, monitoring actual processes as they go on, and often being used for quality control in a lot of different, in a lot of the manufacturing processes. We're seeing a lot more remote experts being pushed into these environments, especially with the pandemic. Experts aren't allowed to travel, and so often the only way to get the expertise into these production environments is to use or to somehow remote. I mentioned as well the improving workers' productivity in those spaces with augmented reality, virtual reality kind of thing. Many more sensors and actuators are being kitted out. Actual parts of the production environment are becoming mobile, where you'll have mobile work cell areas that move around the plant. You'll see as well in many cases the products themselves, especially when they're more complex, sophisticated products with software and electronics on it, they are also requiring wireless connectivity, and especially in the sense of updating software before products leave the production environment. So what does this all mean? We are seeing an explosion of end devices in the production environment. Many of those devices are requiring much more bandwidth than a typical, say, wirelessly connected PLC or other kind of things. Video surveillance and other high bandwidth applications require on your wireless networks. Okay, let's move on. Second question here. We're seeing many types of wireless access technologies find their way into production environments. And with that explosion of use cases I just went to, it's totally expected. You're going to need to use, much more spectrum, different technologies to help, support all of those different use cases and type of applications coming into the production environment. But let's take a further look. What are some of those technologies? Okay. First, you gotta say the two big ones are 5G and Wi-Fi. Predominantly already in many manufacturing environments, but it has typically been used to connect users there back into the enterprise environment. In some cases, they were used to support some of the mobile applications in a production environment, say things running around a track, but it hasn't been, nearly supporting nearly as many use cases as before. And you've also seen, we've seen the 5G service provider and cellular technologies, grow and get more and more capabilities. And as they look to, let's say, capitalize on all the investment that went into 5G, naturally they're looking at manufacturing as a key use case, as a key area, and actually have good technology. In essence, both of those technologies are offering higher and higher data rates, lower latency, increased capacity, in the network, and basically driving IoT at scale. So for Cisco, we consider ourselves, technology agnostic. We're going to support both of these technologies. We're going to try to make sure our customers can manage, secure, and operate all of these different type of wireless access technologies. Therefore, we kind of call it wireless access. But you'll see what those technologies offer. Here, we're kind of plotting things out between what is the typical latency you will see in many of these wireless systems and what is the bandwidth throughput that you'll see through many of those. And we've kind of depicted here in various colors some of the key technologies. In green, you see some of the Wi-Fi where, latencies down to 10 milliseconds can be expected, where you can drive with Wi-Fi up to like Wi-Fi 5, maybe gigabit per second type of bandwidth to those applications. And that's been sufficient to support a number of key use cases in the space. But as I said, we are seeing, expansion out into the augmented virtual reality, driving much higher bandwidth requirements, that video streaming stuff. 5G is well designed to do that. But Wi-Fi 6, I think, as well is well suited to supporting some of those kind of key applications. You also see very low latency requirements in production environments, operating at less than 10 milliseconds, less than a millisecond in some cases, in terms of the control loop. So latency is a real big concern in some of those applications. And 5G is kind of reacting to that with their ultra reliable low latency communication, a new standard or a standard being worked on that really does target taking wireless latencies much lower than the 10 millisecond let's say floor that we've seen to date. So that should give you a little bit of a mixture of some of the use cases, some of the bandwidth latency requirements, and then some of the technologies that might be applicable to them. Next question. One of the biggest challenges is dealing with spectrum in this space. And can I give you a brief overview of how to consider spectrum? Earlier, but they work in different spectrums. And this is going to be a key consideration for manufacturing environments. There's basically two key considerations here when looking at spectrum. Some of the spectrum is unlicensed, also known as ISM bands, where it's generally available to the public for or in private use of that spectrum. So you'll see a number of key technologies working in that space. Wi-Fi is probably the most well known and deployed in the unlicensed space. There's also plenty of licensed spectrum available. Typically, that's been dedicated to service providers who spectrum is licensed or auctioned off, and service providers license that, and then based on that license can provide you spectrums. Down below, we kind of break those spectrum down into three kind of key areas. One, the low band, less than a gigahertz frequency in terms of the wireless spectrum. Those technologies typically go a long distance, have low capacity, and also kind of go through lots of stuff like buildings, walls, or some other things. So they're really good for low bandwidth type of applications, highly geographically dispersed type of applications, right? There are licensed and unlicensed technologies that fit in that spectrum. LoRaWAN, Sigfox, and some 802.11 technologies definitely fit in there, and as well. And there's the mid band, 1 to 6 gigahertz, where you get medium coverage, say hundreds of meters, so to say, versus in the lower ones you can get kilometers or beyond. But in the mid band you get medium coverage and you get medium to high bandwidth. You see some 4G license and 5G technologies in that space, but you also see that's where primarily the Wi-Fi technologies exist, and we list a whole bunch of the different ones, but also 15.4 Bluetooth, wireless HART, ISA 100 are all technologies working in that mid-band unlicensed area. And lastly, you have what's called the millimeter wave, or higher than 6 gigahertz spectrum, and the coverage here is very low, and one of the other considerations is it's also capable of very precise location and other things. So we see millimeter wave being used for some high speed applications. 5G is getting access to some of it. Wi-Fi or 802.11 is also getting some access to it. So you'll see some expansion into that millimeter wave in both the unlicensed and licensed space. So those are some of the key considerations around spectrum. Just to plot things out a little bit differently, we've kind of listed here some of the data rates and the frequency bands and some of the key technologies, right? So you'll see, on the low end, this is for the unlicensed space. On the low bandwidth and less than a gigahertz space, you see the Sigfox and low. Moving up and into the middle, you see the 802.11 space coming in, and then some of the Wi-Fi 6 broadens out into some of the higher frequency and bandwidth spectrums. But this you can kind of use to kind of determine where things fit, okay? Next question, we're hearing a lot of customers asking about 5G LTE, and we wanted to kind of walk through what is that. What are some of the key considerations around that? There is definitely strong use cases for the use of what I would call private cellular deployments. Some of the key companies that are looking at that type of companies, utilities, oil and gas, mining, manufacturing, defense industry, building, so on and so forth. Why are they looking at this? Well, or cellular coverage in a manufacturing plant, there typically aren't those kind of deployments. In oil and gas, just due to the nature of being out in rough and hard to get to places, they don't have a lot of cellular coverage. Again, if you're looking for large geographically distributed systems and environments, these are tend to be some good technologies that the service providers have made sure that technology works on those kind of in those kind of environments. There's also a strong need often for customers to have control, to have independent infrastructure and have control over the operations as well as the security in these environments. What is needed in these private cellular infrastructure deployments? One, in generally speaking around the globe, this kind of spectrum is licensed to service providers, and so either you have to license from them, or come to some sort of arrangement. We are seeing some development in particular countries where some of the spectrum is being auctioned off on much smaller geographical bounds, where, say, a manufacturing plant can buy or acquire licensed spectrum geographical space and use it for example, for production environments and plants. You need the infrastructure to run that. You need devices that are designed to work with these technologies. And there's some considerations about backward compatibility, security, mixing all of this into typically for enterprise customers, fitting this back into all of their IT organizational structures and monitoring and management, security, and all of that. Okay. What we kind of depict here is what's typically needed for a 5G network, just to take a look at it in a different way, starting from the bottom. First and foremost, you need devices that are kitted out with the 5G or some sort of cellular chip, SIM card, and radios to operate. In many in terms of the manufacturing production ecosystem, they haven't gotten quite to the same degree of, let's say, are more and more devices that are coming out LTE or 5G supported. You need basic wireless infrastructure, a packet core for your user data plane kind of transactions. So you need, infrastructure in Wi-Fi. It would be kind of like infrastructure APs, but you basically need your packet core to talk to the end devices and get that information. You might need some multi-access. You can process, route, or analyze some of that traffic coming off of that wireless network. You need a radio access network, a RAN, to start routing those packets where they need to be. You need to manage those wireless APs as well as the devices. And then you need the management functions, and then applications on top of it to manage, monitor, and secure all those environments. So roughly speaking, this is a whole new stack compared to what's already out there in terms of a Wi-Fi. Has some similarities, but it's different technology, needs to be learned, needs to grow and become available, but it does provide a lot of value in cases where you can get through the initial capital expenditure and training and costs. Okay, where does Wi-Fi 6 fit in here? Wi-Fi 6 has basically been adopted into Wi-Fi, into IT infrastructure, and is finding its way also into industrial spaces. 802.11ax is the core of the Wi-Fi 6 standards that has, it's expected to be ratified of the year. And it has some, I think, some really good extensions that help it, that are similar to some of the things that 5G does. Wi-Fi 6 with its E addendum is also going to get more spectrum into some of that millimeter wave to support some higher bandwidth applications. So you can expect some of that to come in 2021. We already see a lot of industrial clients coming out with many of them are already out with the existing 802.11a, g, and AC technologies. Wi-Fi 6 will support those. There is backward compatibility to it. But Wi-Fi 6 devices are also available. Most of the mobile phones, smartphones are already Wi-Fi 6 compatible, and you'll see that continue to extend. And what is your roadmap to Wi-Fi 6? Basically, putting in Wi-Fi 6 APs, which are available now from Cisco and other vendors. But I think a key consideration there is as you put these out there and you notice that a lot of what we've talked about are the higher data rates. Well, when putting those into these production environments, you're going to need your wired network that supports your wireless network to also support those higher bandwidth. And so there's going to be key consideration for Ethernet switches, which support typically now gigabit uplinks, starting to look at 10 to handle, the existing wired traffic along with the added Wi-Fi 6 kind of data rates that are being supported. And just a little bit more detail, what are some of the key enhancements that Wi-Fi 6 is bringing along? First, it is bringing those higher data rates. We can support more devices and with consistently at higher speeds, up to like 9 per radios, and in attended speeds of 1.2 gigabits. But all of this is basically meaning you can run these higher bandwidth applications. That's important. We're increasing the overall capacity in the Wi-Fi network. We're basically supporting more and more devices, one AP, and supporting them better in terms of the data rates and performance as they scale out. Right now, we estimate, you can support 100 devices per AP, which is a significant improvement over some of the previous technology. So you could see more regular Wi-Fi devices or also support higher bandwidth Wi-Fi 6 devices in this space. As well, they've done a lot to improve the power efficiency, so these devices can operate for longer periods of time and with lower power requirements, being able to turn themselves off and other things. So some of those are the key enhancements. And I think, generally speaking, these are very applicable when we look at those use cases that we were reviewing. And then I think, especially want to note, Wi-Fi 6 is mainstream, and that's well ahead of some of the 5G technologies. As I mentioned, the core technologies are expected to be ratified now, but you can already buy Wi-Fi 6 infrastructure APs from a number of vendors, including Cisco. So you'll see that that technology out there already. 5G is coming along. It's coming along very quickly, honestly. Seeing some devices and some infrastructure being deployed, some spectrum being allocated for those kind of environments, but it will be a little bit longer before you see things like URLLC, and I think there's a long way to go to see these deployments more regularly in ecosystem. Okay. Last question. How do you make a decision given all of these different technologies and capabilities and spectrum and all that? And we basically wanted to kind of like paint a little bit of a path. First consideration, do you have devices that can connect? Do you have a range of the sensors or the actuators or the robots? Are they actually kitted out with the technology? What kind of technology they kitted out to work with? What are your key application requirements? I think this is one of the most important ones to look at. What is your bandwidth requirements, your latency, your reliability, your scalability, your ease of use and throughput? All of those kind of key considerations need to be there and to help you to decide. What are you indoor, outdoor, backhauling information, access, wireless access technologies? So that's kind of a key consideration. What are the potential options? We've kind of laid out a lot of those different options, and from spectrum perspective as well as from technology perspective. So take a look at those. And then lastly, I think you got to take all of this and take a look at what's the total cost of ownership. What's the cost to actually buy, procure, and deploy these technologies? What's the cost to operate these technologies? What are the costs on the devices? Are there certain usage, not just capital, but operational expenses that you need to consider? And then lastly, training your staff to support these. A lot of different use cases there. These technologies are being looked at for manufacturing, transportation, mining, utilities, roadways. All of them have some similar but some divergent requirements. But here's a little bit of a path to consider to help you come to some conclusion of which wireless technologies might be good for you and for your use cases. Anyway, that's all I had for today. I wanted to thank you for listening and watching this presentation. I hope you find it valuable. Look me up. I'm at Automation Fair on and off. You can set up a meeting or just come into the Cisco area. Often I should be there and available for a chat. Anyway, that's it. Have a good day and enjoy Automation Fair. Bye.